Hey everybody, I'm back for another half of our video. We're going to take a look at exploring the graphs with your graphing calculator. Since you don't know as much of the details of graphing them by hand yet, we'll just play a little bit there. And then I'm also going to do an example just to review domain and finding intercepts for our rational functions that we're seeing. So part C, again, we're going to go through all the details on how to sketch them by hand, but right now I just want to walk you through how to graph these on your calculator and a couple of quick tips on how to be careful when you're typing them in. So if I can fit this on here, I'm going to put this calculator here. First thing is when you go to y equals, some of these rationals will definitely have like multiple parentheses in places. You really have to be careful with doing like some double parentheses stuff here. So when I type this in, I'm going to do x plus 1. You can follow along with me if you have your calculator. When I hit divided by, I want to make sure that both of these are on the bottom. So I'm going to do double parentheses. And then my x minus 3 will be in the first one. And then I'm going to do another x plus 2. Going to close the x plus 2, and now I'm going to close the entire denominator. So that's kind of important to be able to do. Then when I go, I'm going to hit zoom 6 so that I can actually see the whole graph. And let's see what this funky little thing looks like. Interesting. It kind of looks like that first graph we looked at in part A. It definitely has those three pieces kind of in there. Different calculators will do the asymptotes a little differently, so it's very pixelated, so keep that in mind. But I can definitely see an asymptote kind of right in here, and I'm hoping that you guys can look at the equation and tell me that that value is actually at x equals 3 because it makes the bottom 0. So at x equals 3 we have that vertical asymptote. It's what keeps the graph from going there. And then we also have one at -2, which is kind of right in here. And again, that's coming from this part of the equation. Okay? So if I'm going to kind of sketch that on my paper, if they asked me to kind of sketch that, and we'll talk about some approach statements too. Let's get my axis there, and let's kind of use some orange. We're going to have a piece that goes kind of in the middle, but I need to put my asymptotes in there first. So let's do one at -2, and then there's one at 3. And it looks like kind of a cubic piece here that's going through. I can't tell exactly if it's going through the y-axis at 0. You can actually find x and y intercepts to help, which we'll do on the next one. But I'm just going to generally sketch it. I'm not going to worry so much about that. But it's in general doing this somehow. It's maybe a little flatter. And then it's going to have a piece up here, and then it's going to have a piece down here. So really, it actually looks very similar to the first example we did. If I were to make some approach statements, especially regarding the asymptotes, I could say as x approaches, and let's go to going to the -2. And if we're going from the left, we'll put a negative. And then if I'm going from the left, my function from this side is going towards -infinity. So try the next one. As x approaches -2 from the right, take a moment. What is f of x approaching? Oops, you guys can't see that. Let me see if I can move this over. I just looked up and realized you can't see that. There you go. Well, that gave you enough time to try that one then on your own. Hopefully, if you've already done that, this one from the right is approaching +infinity. Okay? And I think you get the idea. I'm not going to do it for the others, but on your homework, it'll actually say on these problems, I think it'll say something about solve for when f of x is greater than 0. Don't worry about that. We actually want you to just practice the approach statements on it. Okay? So that's actually for number 70 and number 73 on the homework. Okay? Don't worry about the f of x greater than 0 part. Don't worry about that. Okay? All right, last but not least, we saved this for last. It's the review. We figured you should be able to do these on the homework on your own, but you know, an extra couple examples couldn't hurt. So reviewing domain and finding intercepts. Domain is that one. We know a lot of you guys are still working on that, but let's go ahead and take a look here. So domain of this function, let's do domain first. If I'm doing the domain, I'm going to want to know what's going to make this a problem, and the only thing, I don't see any radicals, I don't have to worry about that, but I have a denominator, and I have to make sure that that denominator is not equal to 0, so I need to figure out a way to solve that. Well, it's factorable, so we're going to factor it, and I believe it would be +4 and -3, so that the x values I have to take out of my domain, I can't have it equal to -4, and I cannot have it equal to 3. those are problem areas, what we're going to find is that we're actually going to have most likely vertical asymptotes there. There is another type of discontinuity, but most likely it's vertical asymptotes. Okay, so I'm a huge fan of leaving it like this, but if we say interval notation, you can go negative infinity to -4, -4 to 3, and 3 to infinity. In my opinion, that just takes longer. I prefer that, but there you go. That's the interval notation. Okay, so now intercepts. You should know how to find x and y intercepts. We have been doing that since integrated 1, but we've gradually been stepping up the level of functions. Really a lot in integrated 3, we started stepping it up a lot. So this one does have a little bit more to it, but if we go back to what it means to find the intercepts, a y-intercept, we are plugging in 0 for x. So that's the one that's usually the easiest. We plug in 0, so it's going to be 0 squared plus 5, 0 minus 6, 0 squared plus 0 minus 12. And essentially you get -6 over -12, which we reduce to be 1/2. So remember, intercepts are always points. So our point is 0, 1/2. Okay. All right, last but not least, the x-intercept. This is the one I want to talk to you about. With rationals, what you're going to find is you're going to always have these fractions. And when you're finding an x-intercept, you're setting the whole thing equal to 0. A lot of students will actually make this more difficult than it needs to be. If I want to know when a fraction can equal 0, guess what? I really am not worried about the bottom, because guess what? When the bottom is 0, I already took those values out. That's part of the domain restriction. So I don't care when the bottom is 0. We know already taking these numbers out it's not. But what I do care about is it's when the top is equal to 0. Because 0 over anything is going to be 0. So if I set the top equal to 0, I'm going to factor it and I'll get my 2 values, and I'm going to have 2 x-intercepts. Let's see, this one factors. I think I need a +6 and a -1 to get that correct. So my 2 values are going to be x equals -6 and x equals 1. And of course, we always want them in their proper form. So I'm going to write them like that, as ordered pairs. Okay, so that is a little bit of a review of intercepts, which again you've seen before, but again with the rationals, sometimes you want to kind of know what general approaches you're going to be using most of the time. With rationals, x-intercepts will really always turn into the top equaling 0. I could even actually write that. So set the top equal to 0. And that's true for rationals. Of course, it's not going to work with everything, but really in the rationals, that's what you're looking at. Okay? So I think that concludes our video. I hope you guys find that this will really help get you started on your assignment, which I have typed here at the bottom. This is your assignment. I'll highlight it in a nice bright yellow so you guys can see that. And so hopefully use the rest of class to work on that. Get ready for a big lesson tomorrow. We will really be hitting the ground running with all the details of how to sketch these things. There's lots of details, but if you take it one thing at a time, it is totally doable. But you have to make sure that you are really on it and thinking hard and ready to focus. So we'll see you then, and good luck with everything today.